Dear friends, we are doing the portion in the last unit called hashing. We know hashing is a technology that is used for managing mostly files having many records. We know in most searching, storing methods, the number of records n, the number n matters and n defines a complexity method or complexity of that particular algorithm. But hashing is a method that is very independent of the number n. So let's imagine there is a f, file f having n records, and each record is uniquely identified having a value k belonging to the set of k, and they are going to be stored in the memory location, let's say L, and each memory location is going to be uniquely identified by a small letter L, and there are m memory locations. So what we need to do is, so we have keys, set of keys uniquely identifying a record, and we have memory location. So we are going to store these records into the memory. So in order to store, how do I store a particular record? We do a transformation called hashing. That means it is defined as the process of transforming this k into a memory location L. So hashing is a function that does this particular operation of transforming the value k into a location L in the memory. So let's imagine here. So what we are going to see is, we are just going to take, there are different methods of hashing. We will see it in the coming slide. So let's imagine there are some values, then they are going to be transferred into the memory location. Let's imagine, just for time being, this is your memory space, and these are the memory locations called each by, let's say, L, the set of L, capital L, and each location we are just taking a numeric value 0, 1, 2, 3, and we have values and they get mapped or hashed to a particular location. So that is what is hashing. So this should be able to explain. So this is in fact one of the hashing methods we will see next. So hashing is nothing but the process of transferring the set of k values into the memory location L. So we find, and first we store, then we can search based on the same method. So such a function is independent of the value n, and there are two things that need to be kept in mind when we choose a hash function. It should be easily computable, means I should be able to easily do this hashing on the value, and it should be uniformly distributed, meaning it should have a uniform distribution, so that's to avoid what will have what is called a collision or clustering. We will see these two terms later. So that is hashing. The definition is here. You can go through with this diagram. All right. Now going into different hashing methods or hashing schemes. So there are popularly used three hashing methods called division method, mid-square method, folding method. So what is division method? Let us imagine these are the keys. Now we are just taking numeric value just for an example. Okay. Now what I need to do is I need to hash this value to a particular memory location. Okay. So one method is we find a number, okay, m, such that it is a prime or not easily divisible, and we find the modulus with each k. So I've taken the number 7, then for each number that I have, that is each k that I have, I'm going to calculate the modulus of 7. So I get these values, and the k, that means the record, gets mapped into that location. So let's take 12 modulus 7, I get 5, so 12 gets stored into 5. Okay. Similarly 24 gets into 3, so it goes into 3. 9 gets into 2 modulus, so 9 goes into location 2. So that's how we are taking simple example, and so this is called a division method, where a simple modulus operation is done and we transfer them according to the value received to its corresponding memory location. Of course, examples values taken are symbolic here. Of course, in memory you will have memory space values will be different, but just to implement using a simple array. But this is the logic of division method. All right. Going to the second mid-square method. So here what happens is we find, suppose k is a value 12, we find the square of k and we take the mid value. So for example, if k is 12, that means the key of the record, we find the square of it. So we have 144 and we take the mid value, that is 4. So here are some examples. Of course, these are all symbolic example just to find. Okay, so we have taken some values that are representative. So we take the mid values. So for example, the value 11 would go to location 2. So value 11 k, that means the record 11 goes to 7. Similarly, 16 will go to 5. So 5 location 12. So that is becomes the value computed. So this is called the mid square method. The second, and the third is what is called a folding method. Okay. So in folding method, what happens is, okay, so we need to know that the value k, that is a key of each record, are usually huge numbers. There may be any hexadecimal or numeric numbers, but the k is a huge number. Then what we do is we fold the number of equal parts except maybe the last. Let's say k is folded into different number of digits equal except the last. Then we sum up those ignoring the last carry. So we have, let's say k is 789454, a random number. Then we divide into 3 digits or 3 digits each. So 789 plus 454. We add this, we get this number. Then we ignore the last carry. So 1 is ignored. So it goes to the location memory 243. So if you look at these values, okay, I'm just taking simple values here. 6, 7, 8, 9. So we are going to add 6, 7 and 8, 9. Then we get a number. The last carry is ignored. So 6, 7, 8 will go to the location 56. Okay. So similarly, 1, 2, 2, 3, you get some values here. Okay, 35. So 35, 1, 2, 3. There's no carry here. So examples, okay, are the last is ignored. The last, when you divide, it will, the division is depending on the memory space or memory range of. So if the memory takes 2 digits each, then we get L values into 2 digits. So this is symbolic. So these are the 3 methods of doing and what is called hashing. So once again, hashing independent of the number n, we have seen why, because it is directly transformed into the memory space. And we have 3 methods of hashing. One is called division method. We find modulus and transform. Next is mid square. We square the key, find the mid value and position the records. Third is folding method. That means we fold the numbers of equal digits, add and ignore the last carry. Next is an analysis of a ideal hash function. So when is an hash function ideal or the best? It should have the following properties. Function h should be, of course, easily computable. That means easy to compute. As we saw, it should also be uniformly distributed. That means it should distribute the records uniformly, so that it doesn't get clustered or there are something called collision. And the last, the collision should be minimal, meaning we will study collision in the next video. So what is collision? Suppose 2 records get mapped into a same location, suppose. Okay, that is called collision. So collision is almost unavoidable, but they should be minimum. So that is an ideal hash function. So an ideal hash function are with these properties. All right, next video we will be seeing what is collision and how collisions can be overcome. Thank you.